Hello, in this class we are going to disassemble a fuel cell and reassemble it, and in the process I am going to show you all the interior parts of a single fuel cell, and I will also explain to you what are the possible options that people are looking at for these parts, what are they trying to do with respect to all the hardware design, the design of the materials that go into the actual membrane electrode assembly and so on. So, we have seen them in the form of diagrams in some of our previous classes. In this class we will look at the actual hardware. I will also tell you that this is hardware that we use in the laboratory scale. So, there are some variations when you look at larger scale hardware, but still the similarities are quite significant, and I will also alert you to what changes you can expect when you look at a more industrial type of hardware for the same unit. Okay. So, with these introductory words we will get into this looking at this fuel cell and taking it apart and then looking at its parts. So, we will begin by of course putting on some gloves here. Okay. So, we are ready here. I have with me the hardware, the fuel cell hardware. This is a single cell that I have here. It looks quite bulky, quite heavy. As I said, that is because this is meant for laboratory testing. We want to minimize any artifacts to the data coming from the hardware. So, we do not compromise on the hardware in any manner. We are not worried about the weight of the hardware because we just want to get the functioning of the hardware right. The weight is a consideration that is looked at when this becomes a product. Okay. So, this is the hardware. So, I will show you, even before I disassemble, I will show you a few different aspects of this hardware, and then when we disassemble it you will get a better sense of what those parts are. So, if you see here facing you, you will see this is basically an end plate. So, maybe if you see it little closely, you will see an end plate here and another end plate this side. So, you see one end plate here and one end plate here. So, these are two end plates, and you will see a small hole that is visible here. So, this is the hole through which a heater is put inside this hardware. So, a cartridge heater, it is called a cartridge heater. It simply is a heater in the form of a small rod that is put inside this hardware that helps us heat up this hardware, so that we can run the fuel cell test at a fixed temperature, at whatever temperature you want to run it at. So, if I want to run a control test with the hardware sitting at 60 degrees C, then I can do that. If I want to set it at 70 degrees C or 80 degrees C, I can do that. These are this kind of a cell is typically running below 100 degrees C. It is a proton exchange membrane fuel cell test setup that I am showing you, and so it runs below 100 degrees C. So, that is what you will see on that hardware. Now, if I turn it the other way, complete 180 degrees the other way, you are again seeing the same hardware from the other side. Same thing, two end plates, the same two end plates you are seeing from the other side, and you will see two tiny holes here, one tiny hole here and another tiny hole here. So, that is actually there to simply insert two thermocouples. So, I can independently measure the temperature of this plate here, and I can measure the temperature of this plate here, and that is essential for me for the experiment, for us to keep track of whether the heater is working correctly or not, or to actually give feedback to the heater, because there is a controller which is going to decide whether the heater has to be switched on or switched off, and that is based on the feedback that it is receiving from these thermocouples that are present at these two locations. And you can select which thermocouple you wish to use, and in fact you can also select to have two heaters if you wish on this cell. This particular hardware has been set up with one heater, but you can potentially set this up with two heaters. So, that is the two aspects of the heating of the cell that I indicated. In a real hardware, for example, you would not really be looking at external heat. There the problem is inverted. The cell itself is generating a lot of heat, and we are actually trying to manage the heat. So, there we actually send in coolants to remove the heat, or at least to keep removing the heat at a rate which ensures that the cell remains at some temperature during the duration of the test. But why do we heat this hardware? We are heating this hardware because we only have a single cell here. So, it is not a single cell is not generating, and it is a small cell. I am going to open it and show you, it is a very small cell. So, a single small cell does not generate enough heat to heat up this entire hardware, whereas if it were several cells in series and they were large cells, it would generate so much heat that the temperature of this hardware would keep on rising. So, that therefore, those two situations are different. So, here in this test setup, in order to run this test at some controlled temperature, we require an external heater to be attached to it, and using that we run this test setup. I showed you that we can use a cartridge heater. You can also use flat plate heaters on either side, different ways you can incorporate this heat into the system. So, that is again an experimental variable that a lot of people in their labs will have opportunity to explore and look at. But this is the one implementation of this hardware that I am showing you. Okay. So, now we will look at this side of the hardware. You can see now there are two openings here, one opening there and another opening out here, and this is basically the inlet. The top one is the inlet and the bottom one is the outlet for one of the reactants. It could be any of the reactants. I mean, so one side of the cell will be receiving hydrogen and the other side will be receiving air or oxygen. So, if this were the hydrogen side, you would have the hydrogen inlet. Typically this would be at the top inlet, opening here, and the bottom would be the outlet. Generally we have the outlet at the bottom because you have liquid water being generated in the cell, and therefore, you would like to use the assistance of gravity to get the water removed from the cell. So, that is the reason why we prefer to have the outlet at the bottom rather than at the top. Okay. So, that is the other aspect of it. You can see here a lot of bolts. You can see there are in fact 3 plus 3 6 plus 2 8 bolts that are there in this hardware, and these 8 bolts basically serve to hold the cell together in a proper uniformly compressed manner. So, there is uniform compression across this entire cell, and that is ensured by using these bolts, and that also ensures proper sealing through the cell. So, this is the reason you have so many bolts here. Okay. So, in fact, I am just going to turn this hardware the other way around, and you can see essentially the same kind of layout here. Similarly, the same bolts are now showing up on the other side. The nut bolt arrangement is visible here. You can see that how it has been implemented here, and you also have the inlet and outlet here, the inlet on the top and the outlet at the bottom. So, that is also the same that you see as you saw on the other side. You also see here two copper plates, which again I will show you in a bit of a close up. You can see these copper plates on top, one that is here, and you see another copper plate here. There are two copper plates here which I will just rotate a little bit so you can see more clearly. Yes, there are two copper plates there, two copper plates. They are the ones that are, if I turn it around also you can see the orientation of the copper plate there, and those copper plates basically serve to collect the current. So, when you connect this hardware to the external circuit, this is where the current leads and voltage leads come and clip. They come and clip to this, or they come and clip to this, and that is how you create current into the external circuit. So, that is what is done, and these bolts go, otherwise they go right through. All the bolts that you see here are going right across this hardware from this side to that side, and that is how they hold the hardware together. So, you may wonder that you are short circuiting the cell because this bolt is actually coming from this end plate to this end plate and holding it all together. So, it looks like the hardware is short circuited, but actually that is not the case, because the two end plates that you see here, these two plates that you see here are actually not part of the electrical circuit. There are gaskets which prevent them from being in the external circuit, in the electrical circuit, and as a result they are actually not participating in the path of the current, and therefore it is okay that they are in contact with each other. So, this is the basic hardware that is used in most experimental setups. This is what we have in our lab. We sort of got this made to order, we designed each part and got it made to order, but essentially you can get the same kind of hardware. There are many commercial setups also which sell you these kinds of hardware. We made this in our lab. You basically have to specify the dimensions and orientation of various things, and people can get this made for you. You can machine it and get it done. So, if you have a good machining workshop in your university, you can get one of these made. It is completely doable, right. So, what I am going to do now is I am going to take apart this hardware, open it up and show you all the interior parts of it, and then also discuss more about each of those parts. So, that is what we are going to do now. So, we are going to now take apart this hardware, open it up completely and look at all the parts that are present inside it. So, to do that we are first going to lay it on its side, and there are as you can see 8 bolts out here that we need to open and remove. So, we are just going to do that. So, this will take a couple of moments, but that is part of the process. So, let us do it and get to see what is on the inside. So, by keeping it lying down, we also ensure that the materials that are inside are not disturbed, and that helps us. If we were doing this on a test condition, that would allow us to actually open it up without disturbing the materials inside, and then doing some examination of those materials, and then coming back and reassembling the cell, so that you can actually continue with the test setup. So, this is normally done in all our laboratories. We routinely open up these cells, put in new materials inside and then run the test, and then part way into the test or after some of the testing has been done, if you want to understand why the performance of the cell is a certain value, or if we want to get a sense of what has maybe degraded inside the cell, or some other thing that has happened inside the cell, sometimes it becomes necessary to open the cell and then look at the hardware, look at the interiors of the cell in greater detail. So, therefore, this is commonly done, and it is part of our activity in this fuel cell laboratory testing activities. So, there we are. We have removed all the 8 we opened up all the, we have one more here, 8 nuts and bolts have been opened up, and so I am now in a position to remove the top part of this hardware. We do have the washers, so I will remove them also, otherwise they are all going to come tumbling down, and so I will just do that so that it becomes easier to handle. Alright, so all the washers have now been removed, and we are now in a position to start opening the cell and taking a look at what is inside. So, the first thing that is going to come off is this hardware on top that we are calling the end plate hardware, and so that is what I am going to remove here, and that is just going to gently come right off of this structure. So, this is the end plate. And you can see, you already saw the exterior of this end plate here, and now I am just going to show you the interior. So, on the exterior side you have these two connectors that are present here, and they are basically there are different companies that make these connectors. You can get any connector that you are comfortable with that ensures a good seal and is a reliable connector. Basically, you have to attach a hose here and a hose here, and those two should be supplying the reactants to the cell. So, therefore, you need this to be good connector, reliable connector, leak free connector. So, what you find commercially to do it, you can purchase and fix up. So, now if you turn it the other way around, it is basically flat, it is flat, and this particular piece has been made out of aluminum. You can make it out of stainless steel. Typically for laboratory purposes those should work. They are please keep in mind that this is not going to participate in the electrical circuit. This is not going to participate in the and none of the reactions are going to happen in direct contact with the surface, and therefore the material is really whatever is convenient for you to use. We just need something that is hard and rigid. I mean, at least in this scheme of activity, within the scope of this activity. I mean, any metal should in principle work fine. What we easily get is either aluminum or stainless steel. Stainless steel would also mean it does not corrode under the in the presence of water, and so that is something that you can consider. If you look at say the more industrial implementation of this hardware, this particular piece of the hardware, then people do look at some block of thick block of plastic of different kinds that can be used instead of putting this piece of metal there. But this piece of metal really helps us in the test setup that we use, mainly because as I said, you can put in these connections here for putting the heater, and you can heat the hardware, which may not be, which will be difficult to do if it were some kind of a plastic. So you can put this heater here, heat it, and then that heat will get distributed through this hardware very well, and that becomes easy to use. So that is why we prefer to use this. This side, as I said, are the connections, the connectors, and on the other side you can see, as I turn this around, you have this heating element location. You also have a small hole for putting a thermocouple if you wish. So all those elements are available on this hardware and this piece of hardware, and that is all it does. This is the end plate. This is the exact thing that is also there at the bottom of this hardware. What you see at the bottom is also the same thing, just another piece of it, and when we get to that bottom of this hardware, you will see it. So I am going to set this aside for the moment, and I am going to show you the rest of the pieces one by one, and then after we disassemble the whole cell, we will reassemble it. So you will get a sense of what is involved in reassembling this hardware. It will be done a bit slowly, specifically so you can see how it is done, and you also get a sense of just the handling issues that are involved in putting such a hardware together. So that is the purpose of what I am going to show you. So that is what you are going to see. So I am going to set this aside for the moment. We will get back to it as necessary. So just below that hardware that we removed is this gasket that you see that I am removing from this hardware, and it is basically a silicone gasket. This is essentially a non-conducting material. It is electrically non-conducting. So I am just going to first take it out here, and it is specifically there to isolate that end hardware that I just removed from this cell from the rest of this hardware in terms of electrical contact. So this gasket prevents the hardware that we just removed, which is this one. It prevents this gasket here, prevents this hardware from having any electrical contact with the fuel cell setup which is below this gasket, right. So there is a fuel cell setup below this gasket, and it insulates that setup from this hardware, and therefore that is how this hardware is no longer in the electrical circuit, this entire block that you see here. Okay, so I am going to set this aside, and that, as I said, is the gasket. That gasket actually has, you can see here there are 3 holes in it. 2 of these correspond to the fuel or reactant inlet and outlet, and the third one simply is one of the holes through which one of the bolts goes through this hole, and that is the reason there is a hole there. So that can actually vary from hardware to hardware. So you can have a hardware where the third hole is not necessary because maybe the bolt does not go through this gasket, but in this hardware, given the way the bolts are arranged, one bolt goes through this gasket, and therefore you have 3 holes here. So that is what you will see. So I am going to set this aside and then look at the next part of the hardware. So we are just coming top down. Now one by one we are taking out. I just took out the end plate. Below that was this gasket. So I am going to remove this gasket now. Below that gasket is the current collector. So this is the one. So this is a copper current collector. So I am just taking it out here. This is the copper current collector. So it is made out of copper. I just show you this current collector in different angles. So that is the current collector, and typically we clip onto it here to get it attached to the external circuit. So that is where we clip onto it, and so that is the current collector. You can see the same 3 holes in this as they were as you saw in the gasket, and that is because of the bolts that one through one hole the bolt goes through, and that is this hole here, through this the bolt is going into the through the hardware, and so that it holds the hardware together. These other two holes that you see here are meant for the fuel or reactant inlet and outlet. So, that is the next part of this hardware. So, this is the current collector. Okay. So, again I am going to set this aside. So, 3 pieces out now: the end plate, a gasket, a silicon gasket, and this current collector. So, now since as you know, as I said, since this is called the current collector, it is very much part of the circuit, very much part of the circuit through which the current is being taken from this to the external circuit where you are using it for some particular purpose. Okay. So, therefore, this is very much part of the circuit, and so we need to be aware of what is going on with respect to this, and to ensure that it is not accidentally in contact with the opposite side of the hardware. So, that is very important with respect to this piece of the hardware. So, I am going to set this aside now. Okay. So, below the current collector comes the next piece of the hardware, which is called the flow field or the flow channel, and that is this graphite block. Okay. So, this is a graphite block, and it was face down. I have just I am showing you the back side, the side of it that was on the top, that was facing up is this. It is featureless on the top, you do not see any features on it. What you will not see very if you watch carefully, you will see 2 tiny holes here. I am trying to position it so that that becomes visible to you. Yes, that you now you will be able to see 2 tiny holes. So, I will point to them in just a moment. So, there is you see one hole out here, or at least one indication that there is something there, there is a tiny hole there, right, and at the diametrically opposite end there is a tiny hole. So, it is through these are the 2 holes that line up with those inlet and outlet that you saw in the rest of the hardware, and that is how the gas goes in and out of this hardware. Okay. So, so this is called the flow channel, gas flow field, and on the back side of it, which is what you are currently seeing, it is featureless, and that is therefore, you will wonder what is where is the scope of anything flowing in it. But in the back side of it, there is no reason for anything to flow. It simply goes into this hole that you see here and goes to the other side, which is the front side of this flow channel, and I am going to turn it around and show you the front side of the flow channel. So, the front side of the flow channel is the one that is facing the membrane electrode assembly, which is where all the reactions are taking place. So, the front side is where you need to have all the features. So, let me turn it around and show you the front side. This is the front side of this flow channel. You can see that it has some flow pattern in it. Let me change the position of it so you can get a better sense of it. Yeah, there you get to see the flow channel. You will see here actually a set of a channel that goes up and down, up and down, up and down in a serpentine manner. Okay. So, it goes up and down, up and down, up and down in a serpentine manner. It is very narrowly spaced set of channels, and so that is you have to watch carefully to see it, but you can see that channel. So, what normally happens is the gas enters, let us say it enters here, and then it is just going to go down and then come up and then go down and then come up, etc., and then come out finally to the diagonally opposite end, and at that point it will come out through the back side of the flow channel and exit out the cell. Okay. So, this is how the gas in this fuel cell is distributed through to the entire cell where the reaction is taking place, and that membrane electrode assembly is very close to this surface. It is not in direct contact with the surface. There is one more layer in between, and so we are going to talk about that layer, but that is the first thing that distributes the gas is this gas flow field, and that is what you are seeing out here at the moment. So, I am going to set this aside, and then we look at the next few parts that are remaining in this hardware. So, right now once you come this far into this hardware, there are actually you have to come actually very close to the fuel cell itself, which is this layer that I am going to start taking out now. We are just one sort of one layer away from the actual fuel cell or the membrane electrode assembly, but the layer we are currently dealing with has 2 parts in it. One is the gasket and the other is the gas diffusion layer. So, I am going to take out both of them and then show that to you. So, the first is this gasket. you can see that this is basically a square window of sorts, and this is made out of Teflon as the material. It is basically there to ensure that first of all no gas leaks out of the cell. So, you do not want gas leaking out of the cell, and so therefore, you need this gasket. And the second thing it does is the thickness of this gasket is an important parameter that decides how much the remaining parts of the cell which consists of the membrane electrode assembly and the gas diffusion layers, how much they get compressed is decided by the thickness of this gasket, because this gasket usually does not compress a whole lot. And so, when the hardware comes to a halt at this gasket, the gas diffusion layer has been compressed to some degree. You want the gas diffusion layer to be compressed to some degree, because only then you will have good electrical contact with the gas diffusion layer. If you just barely touch the gas diffusion layer, if the current collector just barely touches the gas diffusion layer, or if the the gas flow channel just barely touches the gas diffusion layer, then you will not have good electrical contact. You will lose electrical contact, you will have high contact resistance. So, you do need it to be compressed a little bit, you want that compression to be there a little bit, and so that you get good contact with the gas diffusion layer. But at the same time, if you compress it too much, the gas diffusion layer gets crushed, and that is also not particularly good, because that will completely destroy the gas diffusion characteristics of the gas diffusion layer. So, you want some compression, but not too much compression. So, that limited compression that you want is ensured by putting a gasket of some appropriate thickness. This is not very thick, it is relatively thin, but the measurement is decided based on that requirement, that you need sealing and you need some compression, but you do not want the materials to be crushed. That is the purpose of this gasket. Okay. So, that is there in this layer, I am going to set that aside, and this layer that is just alongside the gasket is the gas diffusion layer. So, this is the gas diffusion layer that I am presently holding in my hand. This typically is a carbon cloth or a carbon paper, and there are people doing different kinds of research activities to see if there are alternatives to this, different ways in which you can implement this particular layer, so that you can get the properties that it is supposed to have, or even improve on those properties that it has. So, but this is the gas diffusion layer, gas goes through it and distributes across to the membrane, all the active sites of the membrane electrode assembly. It is a porous carbon cloth or carbon paper. Sometimes it has a layer on top called the micro layer, which has better conductivity, but those are all various implementations of this gas diffusion layer, and if you are really doing active research in this area, then those are kinds of parameters that you will focus on and try to make some variations on. Okay. So, that is what this gas diffusion layer is. So, that is one more part that I am just now going to set aside, and now we come to the most important part of the fuel cell, which is the membrane electrode assembly, and that is the layer that I am pulling out now. Okay. So, as I turn it around, yes, there you can see clearly the reflection of the membrane all around. So, you can see that there is a larger membrane, and in the center there is a in the center you see the squarish electrodes, right. So, those electrodes are actually catalyst layers that have been painted or deposited onto this membrane, this relatively clear membrane that I am holding in my hand, clear transparent membrane that you see. That is the nature of the membranes used for this activity, and on that you put this catalyst layer on either side. So, actually there is a layer on this side, and if I turn it around carefully, although you may not be able to see it properly, there is a layer on the other side as well. So, both sides have the same layer and they are aligned on top of each other. So, and since the membrane is transparent, you do not I mean looking at it, it looks like the same thing, but actually this side you are seeing one catalyst layer, and as I turn it around you are seeing the other catalyst layer. So, these are the two catalyst layers, depending on your test they may be the same, or you may have actually totally different compositions on these two catalyst layers. So, you have the option of doing that, but then you also have this membrane, membrane that is there. This membrane is the important thing in this setup, in the sense that it is the electrolyte, and the two catalyst layers are the ones where the electricity is generated, or the reactions occur rather. So, you have an electrochemical reaction occurring at the anode, and another electrochemical reaction occurring at the cathode, and so one of these layers is the anode and what is behind is the cathode. So, we can, if we assume that this is the anode, or if we have decided that this is the anode, then this becomes the cathode, the layer behind becomes the cathode, and in between the two layers is this membrane. So, this is the membrane electrode assembly. Okay. So, this is the membrane and electrode being assembled together, it is called the membrane electrode assembly, and this is the central part of the fuel cell. On either side of this membrane electrode assembly is the gas diffusion layer, then there are two gaskets, there are flow channels, and then there is a current collector, one more gasket, and then the end hardware. So, we have come to the center of the fuel cell. So, what remains will be an exact replica of what we just took apart so far. So, I will just pull out those parts and show you that on the other half of the fuel cell also we have exactly the same parts. So, just below it is one more gas diffusion layer and a gasket. So, a gas diffusion layer and a gasket, and this will typically fit inside, this will fit inside this regime there. So, you can see that it fits inside, you can pull it apart and then it comes off separately, right. So, this comes apart and you can put it together that way. So, so that is how they fit inside each other, that is how they are sized. If you size it such that they do not overlap, that they just about fit, the gas diffusion layer just about fits inside the gasket layer that is provided, right. So, that is the way we assemble it. So, these two are there. So, I am setting that aside, and then below it is the next flow channel that you see here. Again you can see the serpentine flow channel. It is called serpentine because it goes up and down and curves, it is basically like a straight line that goes straight down, then curves and comes right back, then curves and goes down again, and so on, and that is called a single channel serpentine flow pattern, and that is what is implemented in this hardware. You can have other forms of hardware where you can have different versions of this pattern. I will also tell you that in material sense, like this is this end hardware that you see here, this flow channel that you see here has been made out of a block of graphite. Okay, so, a block of graphite was taken, so that is why it looks like this. You can get commercially these blocks of graphite, and then you can machine whatever pattern you want into it. So, this pattern has been machined into it, and then it is being used as a flow channel. In an industrial setup, if you are trying to make fuel cells in larger scale, then taking graphite blocks and machining them is not a convenient way to do this. In fact, they will break, they are not very easy to handle, and they are also kind of, as you can see here, this is of reasonable dimension, even thickness wise there is some reasonable dimension to it, maybe it is about this probably is about 4-5 millimeters thick, and you can see that it is several millimeters thick there. So, this is not the way we would do it in an industrial setup. We would actually use composite plates made out of polymer based composites, which have enough additives to it, maybe carbon based additives, to ensure good electrical conductivity. This plate is supposed to have good electrical conductivity because it is whatever electricity you generate in the membrane electrode assembly has to come through the GDL, arrive at this plate. From this plate it should go to the current collector, and from the current collector it goes to the external circuit. So, this has to have good electrical conductivity. It should also be non-porous, unlike the gas diffusion layer where you need porosity to get the gases to go to the reaction sites. This flow channel has to be non-porous because you do not want gas to escape from this flow channel and go to the go outside. Therefore, this has to remain non-porous. Okay, so this has to remain non-porous and as thin as possible with good electrical conductivity. So, that is kind of what is desired here. Okay, so I will set that aside. So, what remains in here is simply back, we are once again back to yet another current collector that you see here, the same thing that we just saw a short while ago at the top side of the cell. So, I will set that aside, and one more gasket layer that we saw here, and we are now back to the remaining part of the hardware, which is simply this end plate with all the nuts and bolts. So, so this is basically the hardware that we have for our fuel cell. So, you have essentially seen the full hardware taken apart, all the parts that are involved have been pulled aside. So, it is also of interest, I mean, and I have explained to you what are all the requirements we have for each of these parts. We have also discussed them in some of our theory classes. This was in an class where I wanted to show you the actual physical hardware and how it all comes apart and how it all comes together. I have so far shown you how it all comes apart. I will take the next several minutes to put it back together and then show you how it all it can be built up. So, to do that we actually need to take the help of two tiny assistants, and I will introduce them to you. These two tiny wires that you see in my hand, that you see there, and this one that is on my other hand. Yes, there, I think you get to see it now. Yeah, there you are. Yes, there you see it. So, these are two basically wire like structures. They are wires essentially. They are used as aligning pins. So, I have to use this to get, these are all thin layers that I just showed you. I need them to line up correctly and perfectly, and so I use this to assist me in the process, and this is just an aligning pin. So, I will insert this in this hardware and use this aligning pins to help me align all the layers that come one on top of the other. And when I am done with the assembly, I will simply pull out these aligning pins from this hardware, and at that point these aligning pins are no longer necessary for this build for the rest of the testing. So, that is what we are going to do now, and first we will insert the aligning pins into this hardware and then start from there. So, there is a tiny hole which is down here that I can see, and so I first insert this aligning pin carefully through that hole. So, this is a little bit of a slow process because we need to do this correctly, and so it takes a little while to assemble a cell. Yeah, if you ever were to do this kind of fuel cell testing, you will find that at least in your initial tests, to get the cell to be built correctly without any leaks, assembled properly, is itself a reasonable challenge. We do, in fact, after we do the assembly, we do a leak check and we do a short circuit check. We want to ensure that there are no leaks and there are no short circuits, and just ensuring those two, at least the first few times you build a fuel cell, can sometimes be a little frustrating till you figure out all those small minor details that help you set it up so that there is no leak and no short circuit. So, in any case, now I have inserted the two aligning pins. I am going to take this hardware and then make it horizontal. There you go. We got it horizontal, and on this I can start building my cell. So, as I said, the first part that will go on is a silicone gasket that helps us isolate this hardware from the circuit, and so that is this gasket that we were referring to, and it has three holes. So, one is for the bolt and the other two are for the gas flow channels that are present in this. Yeah, so that is the orientation. So, we have to look at the orientation. So, now I have three holes here. They are oriented so that one lines up with this one lines up with the bolt, and these two that are here line up with the inlet and outlet of the flow patterns. There are also two tiny marks in that on it which are the places where the aligning pins have to go through, and so I am going to send the aligning pins through it and then assemble it. So, there I am putting the aligning pin through this here, and I also have to line it up with the aligning pin on the other side. So, we do that. Yes, it is now into the aligning pins, and I begin to slide it down. I also get the bolt to go through it, and it goes all the way down and it settles down here. So, when I do that, you can see here now that I have got it in position like that. You can see that the holes are lined up, the inlet, and there is the outlet, or yeah. So, the two inlet and outlet for the reactant streams have been lined up correctly with the gasket that I just put, right. So, now again put it back to flat position, push the gasket back down, and I take the current collector is there. So, again I have to get this current collector to go in. with the alignment pins going through the current collector. So, all these parts have this tiny hole through which that alignment pin has to go. Only then it lines up correctly and it goes right through, and I put it down. There are a few extra O-rings that are also put at the inlet and outlet stream to ensure that it stays leak tight, but that is not immediately of most importance to us in this what we are discussing. But here it is, I have now put the current collector in place. So, I will show that to you. There you go, the current collector is in place, and so is the first gasket layer. So, what I put there, the silicone gasket layer as well as the current collector are all lined up correctly with the rest of the hardware. So, that was the purpose of those aligning pins, and you can see that now that the aligning pins are, because of those too thin wires that we had as the aligning pins, we are able to do that quite effectively. There is a pin here which I think you can see there, maybe that you can probably see the pin here. So, that is one pin, and this is another pin that is out here, that I am holding out here. So, those are 2 pins that are sticking out, and using that I have done this alignment. So, now I am going to put it back in the flat position and then assemble the rest of the hardware, and then we will look at it. Okay, so now that we have these pieces in place, our next part to put here is the flow field. So, the flow field I have in my hand. So, flow field has to be in electrical contact with the current collector. So, therefore, we are not putting any silicone gasket between them. It also has alignment pins. So, we have to line up with the alignment pins and put it in. So, it is exactly what I am doing. I put the alignment pin through it and another alignment pin here through it. Okay, so, it is all done, it goes neatly back down. So, that is the flow channel. You can see here now with the flow channel how the hardware looks. As I tilt it towards you and show it to you. So, this is with the flow channel in place. You can see everything is in place and they are all lined up because of the alignment pins. So, the alignment pins are very critical for us. I am able to hold it in one hand and show it to you because of the alignment pins, and you can see all of them, all of those layers are now one on top of the other. The silicone gasket is not visible because it is behind the copper current collector and between the copper current collector and the end plate. So, that is why it is not visible, but you see the end plate, you see the copper current collector, and you also see the gas flow channel. All 3 of them are visible. So, again we will lay it back in the horizontal orientation, and we will start now assemble the cell itself. So, to do that, first thing we need is one more gasket, that square gasket that we spoke about. So, that we will put here. Yes, that side went through the aligning pin. Now, I got to get this side to go through the aligning pin. Yes, it is through the aligning pin and it is down to the bottom. Then I am going to put the gas diffusion layer. I am just going to go and sit there. So, now those 2 are sitting there. I can't lift this up, well I can, let me try to lift it up and show you. Because I have to ensure that the bolts also do not just fall right out. There you are, you can see how this thing is oriented and all those units are there. So, I will just put it back down. I think I had one bolt come off, but that is okay, we can put it back there. We got everything in more or less. Only one bolt is off, we will put that in just a moment. Yes, there we are, we have got everything in and everything in place. So, now the next thing that comes is the membrane electrode assembly that you have here, membrane electrode assembly. So, that is what I am going to put on top of the arrangement that we have so far. That also has those two small tiny holes for the alignment pin. So, that helps us align it correctly. So, I got it through on one side. I am trying to get it through on the other side, let us see. Yes, it is through. So, we have got the membrane electrode assembly also to go in. So, it is now sitting on the hardware with everything the way we just described, and so that is in place. You can sort of see it even from that orientation. As I rotate it along, you can see that it is sitting in here. That is the membrane electrode assembly. So, on top of this, I am going to put the next GDL, gas diffusion layer. So, the gas diffusion layer that was put in the beginning, the previous gas diffusion layer was on one side of the membrane electrode assembly. Now, I have put one more gas diffusion layer which is on the other side of the membrane electrode assembly, and I am going to put this next gasket. So, that is what this gasket is. I am going to put it up here. Same thing, we have the alignment pins. I have to line it up and then put it through. Yes, it is in one aligning pin. And almost in here, not yet. Yes, it is in. So, I have got the second gasket also in. So, on both sides of the membrane electrode assembly, I now have gas diffusion layer as well as the gasket on both sides. So, a peripheral gasket, and in the center there is a gas diffusion layer. So, centrally there is a gas diffusion layer, and on the periphery you have this gasket, and this is there on both sides of the fuel cell. So, this is the peripheral gasket, both sides of the membrane electrode assembly. So, we got several of the major parts in. Now, I am going to on top of this, the next part that needs to come is the other flow channel, the flow channel on the other side of the cell. So, we have already seen one side of the cell, we are seeing the other side of the cell. So, this flow channel needs to come on this side of the cell, and so again we take the aligning pins and line it up with this line up this part with the aligning pins and send it through, so that it lines up correctly. So, I take that up here, I see an aligning pin here. So, a hole for the aligning pin. So, I am going to send that in. Yes, that is in on that side. Yes, it is in on this side as well, right. So, it just goes straight down, you can see it going down, goes down, 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 and sits in, perfect. So, we can see that this is now settled in correctly. We ensure that by just holding it down, we do not have any non-uniform, improperly aligned hardware. We just ensure that it is aligned properly. And so, the next piece of hardware that needs to come on top of this is the other current collector, which is the copper current collector. So, I have one more of these here. So, that is what we need to put here, and so that is what we are going to do. So, I am going to take it up here, and you can see here again there are three holes in this. So, two are for the gas inlet and outlet, that is this, and this is where one of the bolts goes through. As I mentioned, that is just the design of this hardware that has this situation. So, now I am going to do that and build it up. So, we will put this aligning pin here. Yes, it is through the aligning pin, and this other aligning pin is lined up there. Yes, it is through. So, the two aligning pins are now through, and it also goes through the bolt and it comes right down. So, that is our cell with the two current collectors that have been assembled. So, we just need to put one more gasket layer on top of this and put the rest of the end hardware and close the cell. So, that gasket layer is what I have here. It consists of those same three holes that I mentioned. one for the inlet and outlet. This pair is for the inlet and outlet. This is the inlet, this is the outlet, and this is where the bolt will have to go through. So, same drill, move it up here, we line it up with the alignment pin. Yes, that went right through, and this side I have to put it through the alignment pin. Yes, that is also through. You can see it is now standing on those two alignment pins, and as I slowly slide it down, you see it goes through the bolt. I can slide it further down, and it is now all the way down. So, you can see now I just tilt it over, and then I will show you how it is all lined up. There you are. I managed to do it without having it all fall apart, but there you can see if I rotate it, you can see the two holes, and you can even see that the hole is going right through. You can see that hole of the current collector also lining up with this gasket. So, you need that because the gas has to go through, right. So, I am going to hold that together and make it all lie down. Yes, there we are. So, last part remaining here is the end plate that I am going to put on top, which is the same as the end plate that you see at the bottom, and with that we can close the cell, we can put the complete the nuts and bolts, and that completes this cell hardware. So, that is what I have here, the hardware, the end hardware. This side has to face the cell, this is the external side. So, I make sure that I do not get that wrong, and also the same orientation should be there for those two inlets and outlets. With that in mind, I take it up. Again, there is the same two aligning pins are there, holes are there for that. So, I have to make sure it goes through that. Yes, the first aligning pin went right through, and let us look at the second one. Yes, it went right through too. So, now you have all the holes for the bolts, and I just have to line them up so that they all neatly go through their respective sockets. Yes, there you go. Then I just look and make sure it is all sitting correctly, and then I put all the washers. So, at first in any of these hardware builds that you make, usually it is all set up like this, such that everything is sitting horizontal. That way you can align things well. So, what you saw here, for example, was a single membrane electrode assembly in the middle, and so it only had one pair of GDLs and one pair of flow channels, one pair of electrodes. So, this is what we had. We had a single membrane pair of electrodes on either side, which were already sort of attached to that membrane, and then one pair of GDLs on either side of that, and one pair of flow channels. Now, if you actually have a stack which we discussed in the class, then you will actually have several such cells in series, and therefore you need to assemble after you put the flow channel. The flow channel will then touch the flow channel of the next cell. So, the back side of the flow channel of one cell will touch the front side of the flow channel of the second cell. So, in fact, what they do is they have plates which are called bipolar plates. They will have the flow pattern of the anode on one side and the flow pattern of the cathode on the other side, so that one side becomes the anode of one cell and the other side becomes the cathode of the other cell. So, when you do that, you have to have everything horizontally located. So, you can put one cell, and then on top of it you can put the next cell, then on top of it you can put the next cell, and so on. So, you keep on building the cells, and so in that process you stack it up steadily, and so you will put one end plate at the bottom, and then instead of just one cell here, you will put the second cell, third cell, fourth cell, fifth cell, whatever. If it is a 10 cell stack, you will have 10 cells, and only then the second hardware will come. This second end plate will come on top of the 10th cell. Other cells will be attached connected in series. So, usually you will have all these bolts standing vertically up, and then all of these parts coming in one by one. So, you sit and assemble them one by one till you get all these 10 to line up correctly, and then you put these bolts and then you tighten them up. So, tighten them up. So, normally also we simply hand tight them the way I am just doing it right now, and so that is the first stage of this build, which is to hand tight everything so that they are firm, they are not loose. So, if I hand tighten all of them, at that point it is actually quite okay for you to lift it up and you can see the hardware, it is not going to fall apart, it is going to stand on its own, it is already tightened the way we want it to be tightened. What remains is actually simply based on this build, the specification of the build, we will look at we can specify a torque value for each of this bolts, and therefore you can put a torque wrench and then hold it on one side. So, like this, so you will hold it on one side and you will have a torque wrench on the other side, and then you tighten it till you reach the correct torque. So, on each bolt you can reach the correct torque, and that way you ensure uniform compression of this hardware in all directions. So, right now I have only done hand tightening on all the bolts, but that is okay for the first step of this build. You actually have to have a torque wrench with which you will apply a predetermined amount of torque, and then at that point you have put the right kind of compression on this hardware so that it both seals as well as there is good electrical contact at various locations within this hardware. So, that is how you would build this hardware. Of course, one last step remains. Once you are done with this complete hardware building, you still have this aligning pins that are sitting in this hardware, which I can slide out. So, I can show you here, this is one aligning pin, and I can pull out this other aligning pin here which is sitting here. So, there are two aligning pins here, there is one here and there is one here. So, if you see carefully you can see those aligning pins, one here and one here. So, I am just going to pull it out slowly. So, let me line it up here and then you can possibly see it. I begin to pull it out, there you see the pin, I am pulling it out. So, that is the pin, pull it out, it comes right out. There, the pin has been removed, the aligning pin has now been removed from the cell. So, one aligning pin was removed in that format, and I am going to remove this other aligning pin here. Hopefully, you can see that, yeah, there you can see that pin, and I can just pull it right out, there it has been pulled out. So, both the aligning pins are out. If the aligning pin remains, it does do some short circuit of the cell, because it is going from one side of the hardware to the other side of the hardware. It is connecting one current collector to the other current collector. So, it will do a short circuit of the cell. So, you cannot leave the aligning pin in while you still do the test, at least not a metallic alignment pin. If you do have a plastic alignment pin, you can do that, that is not a problem, or a non-conducting alignment pin. So, based on your hardware, the exact details of each of these parts may vary, but or wherever you are working on this kind of activity. But broadly what I just showed you is what is there in a fuel cell hardware. Very broadly speaking, this is what is there in a fuel cell hardware. This is what we use in our lab to do our testing, so it is a pretty good representation of what you can expect in a fuel cell test setup, and also in a fuel cell hardware anywhere that you encounter it. At least you will be able to relate what you have seen here to any part that you see in the in any other hardware that you see. You will see some variations on it, you will see some variations on the pattern that is used in the flow channel, the sizing of the flow channels, sizing of the overall electrode area also. So, for example, the electrode area I just showed you was 2.5 centimeters by 2.5 centimeters. So, an active area of about 6.25 centimeters square. But that is just because it is a test cell where we want a controlled area over which across which we know what the test conditions are. But real hardware we may have 10 centimeters by 10 centimeters, which is 100 centimeter square active area. So, that will be much larger. So, you will have significantly large 10 centimeter by some 10 centimeter kind of situation, and so that sized square you will have, that is just the active area as opposed to the small stamp sized active area that we just saw in this test hardware. So, those kinds of variations you will have, variations on the dimensions of this end hardware, variations in the way in which it is bolted together, how many bolts you are using, what kind of bolts you are using there. You will also have variation in the thickness of those flow channels, and as I said, is it a graphite flow channel, is it a metallic flow channel, is it a composite flow channel. So, wide range of varieties like that, and the flow pattern inside it can be different, the gas diffusion layer material can be different, MEA can be different. But whatever hardware you see, I think you can pretty nicely relate it to what you have seen here. I also showed you this hardware with flat gaskets. You may have gaskets that are circular in cross section, and also because it is a single cell, we have some liberty in the sense that some advantages in the sense that I can comfortably set it up such that on one side I have the flow inlet and outlet for one gas, and I can just turn it around and I have the inlet and outlet for the other gas, right. And this I am able to do only because it happens to have only one cell inside it. If I have a series of cells inside it, lot of cells inside it, first cell, second cell, third cell, fourth cell and so on, then it is not easy for me to, I cannot just have one gas coming from one end and another gas coming from the other end, because it is not only there, it has got more than two sides. So you need gas, hydrogen gas to go to the anode side of each cell. So if I keep it like this, if there is a first cell and then there is a second cell and a third cell, let us say there are 3 cells here, first, second and third, I need hydrogen gas to come to the anode side of the first cell, then not go to the cathode side but come to the anode side of the second cell, not go to the cathode of the second cell but come again to the anode of the third cell, and so on. So similarly air would also have to come to the cathode of the first cell, skip the anode of the second cell, come to the cathode of the second cell, skip the anode of the third cell, come to the cathode of the third cell. So that is the kind of control I need to have on the path travelled by the gas, and so that is done based on a different layout of how the gas flows from cell to cell to cell. So, some changes like this you will see in the hardware, but I think what you saw today will give you a much better perspective of any hardware that you get to see for a fuel cell activity. So I think that was the purpose of this class, and I think you will find this informative to you if you ever happen to look at fuel cell hardware. Thank you.